The size of a confidence interval can usually be made smaller by starting with a bigger sample. For example, consider computing a confidence interval for a proportion using a sample with size n equals 50 and sample proportion 0.6. These values satisfy the requirements for using the normal distribution to approximate the binomial distribution, since n times the sample proportion and n times 1 minus the sample proportion are both greater than 10. So a 95% confidence interval can be computed as in the previous section by calculating the standard error and the critical value z star and inserting those values into the formula for the endpoints of the interval. To see the effective sample size, now repeat that calculation for a sample that is 4 times bigger, or n equals 200, and 4 times bigger than that, or n equals 800. Here's a number line plot of those three confidence intervals. When the sample size increases by a factor of 4, the length of the confidence interval decreases by a factor of 2, so the confidence interval for n equals 200 is half as big as the confidence interval for n equals 50, and the confidence interval for n equals 800 is half as big as the confidence interval for n equals 200. This effect can also be predicted by considering the formula for the confidence interval. The product of the critical value and the standard error is the margin of error, which is the distance between the sample proportion and the endpoints of the confidence interval. From this formula for the margin of error, it can be seen that if the critical value and the sample proportion remain the same, the margin of error and the size of the confidence interval will be proportional to 1 over the square root of n. A useful approximate relationship between the sample size and the margin of error can be computed by setting up typical values for the sample proportion and the critical value and evaluating the formula for the margin of error for a symbolic value of n. The result shows that the margin of error is the product of a numerical factor, which is typically close to 1, and 1 over the square root of n. So, at least approximately, the margin of error for a 95% confidence interval for a proportion is about 1 over the square root of n. This means, for example, that for a sample size of 100, the margin of error is about 10%. For a sample size of 1,000, the margin of error is about 3%. And to get a margin of error of 1%, the sample size has to be almost 10,000. When reporting confidence intervals, rather than giving the endpoints of the confidence interval, it is common to instead report the point estimate and the margin of error. For example, consider reporting the confidence interval that is computed by these inputs, which give a confidence interval for a proportion, starting with a sample where n equals 1,000 and the sample proportion is 0.6. The margin of error in this example is about 3%. The confidence interval in this example can be reported either by giving the point estimate of 60% and the endpoints of the confidence interval, which extends from about 57% to about 63%, or by giving the point estimate and the 3% margin of error. Almost any confidence interval can be reported in either of these two ways. The second way is especially common when reporting confidence intervals for proportions. Both descriptions provide the same information, so the choice of whether to give the endpoints of the interval or the point estimate and the margin of error typically depends on the application or on the preferences of whoever will be using the information.